Hello my dear students, welcome to your Geography's online class. Today in this class we will be discussing about the chapter Atmospheric Temperature. In this chapter we will need to learn about what an atmospheric temperature is all about and how they are being affected. So in this term, let us first start discussing about the solar radiation. Solar radiation is the heat emitted by the sun. So if you see in this diagram, here this is the sun and this is the earth. The sun is a hot and glowing object which has its own heat and light. So this heat and light energy is given out, that means radiated out of the sun. And this radiated energy is known as solar radiation as it's coming from the sun. This very solar radiation that is emitted out of the sun reaches the earth's surface and in turn hits the earth's surface. Not just the earth's surface but also its atmosphere. So here, from here as it comes out, it is known as solar radiation, but as soon as it reaches the earth's surface and starts hitting the earth's surface, then on a receiving end for the earth it becomes insolation. For the earth it becomes insolation. Now this insolation is the incoming rays of the sun for the earth when we discuss. But when we talk about solar radiation, we would say it is the heat energy that is radiated out of the sun. And then from on the earth, being on the earth, we would say now since we are receiving the heat of the sun or the light of the sun, we would say it is the incoming rays of the sun for us on earth. So hence that becomes insolation. Now this insolation or the incoming rays of the sun is also known as short wave radiation. As it covers a shorter distance, hence we call it a short wave radiation. Now there are also different factors that affects the insolation, and also with this incoming rays of the sun, that is insolation, not every amount of the heat energy radiated from the sun reaches the earth's surface. So now let us discuss about those balance that has been made to what is we call heat budget or heat balance. So heat budget, when we talk about heat budget, we just say is as a balance between the incoming and the outgoing rays of the sun. So let us see through this diagram or try and understand through this diagram. The sun emits the heat energy out of it to what is we call solar radiation. The earth receives it. The earth is on its receiving end while the sun is giving out its energy. So in this case, what we find or what it happens is the heat energy that travels from the sun till the earth is obstructed on many cases. So the obstruction first of all comes from the atmosphere. The clouds that forms on the atmosphere, and then we find also from the earth's surface. So if we consider the sun giving out 100 units, say that the sun gives out 100 units of heat, then before reaching the earth's surface or without heating the earth's surface, we say 35 units. 35 units out of this 100 units reflects back to the earth's surface, either because of the atmosphere or because of the clouds that are formed on the atmosphere or because of the snowy land that is present on the earth's surface. So they completely reflect back the heat. 35 units reflected back without much heating the atmosphere. So out of this 100 units, if you take 35 units out, how much remains? Is it's only 65%. Or you say 65 units. Out of the 65 remaining units, the atmosphere of the earth absorbs near about 14 units of it. This 14 units is absorbed by the earth's atmosphere, and then this helps in heating the atmosphere of the earth. Now if you have 14 units been taken out from 65, then it remains 51 units. So the actual heat reaching the earth's surface will be how much? 51 units. Out of the 100 units, once again if we see, the 14 units of this heat radiated out of the sun is absorbed by atmosphere. 35 units is reflected back. This 35 units which is reflected back without much heating the atmosphere is known as albedo. This is known as albedo. Now the remaining 51 units out of 100 units actually reaches the earth's surface, which now starts heating the surface of the earth. Now the earth's surface, once it starts heating in itself, it also starts radiating back the heat. And that heat which is radiated back from the earth's surface is known as terrestrial radiation. So terrestrial radiation or terrestrial heat with this 51 units after heating the earth's atmosphere. Now this terrestrial heat which comes out of the earth's surface after heating the earth, that is with 51 units, 34% is again absorbed by the earth's atmosphere. 34% is again absorbed by the atmosphere. So out of this 51, 34 is absorbed by the atmosphere. So finally 17 units again is completely reflected back on the earth's surface, this space. So this balancing of incoming and outgoing radiation to what is we call heat balance. Once again if you see that out of the 100 units that radiates from the earth, the sun in fact, 35 units it reflects back to the space without much heating the earth's atmosphere and the earth's surface. With 35 being reflected back as albedo, it remains with only 65 units, and of the 65 units, 14 units is absorbed by the atmosphere. And then again, the remaining 51 units finally reaches the earth's surface, which thereafter again hits the earth's surface, and on hitting the earth's surface, the earth itself radiates back the heat to what is we call terrestrial heat or terrestrial radiation. Of this terrestrial radiation coming out of the earth, 34% is absorbed by the earth's atmosphere again, and then 17% is completely reflected back to the space. So this balance between the incoming and outgoing radiations of the sun is known as heat budget. Now in this heat budget, the incoming rays of the sun to what is we call insolation, like I said earlier, is also known as short wave radiation. And the terrestrial heat that comes out of the earth's surface after heating the earth is known as long wave radiation. The terrestrial heat is also known as long wave radiation, while insolation, that is the incoming rays of the sun, is also known as short wave radiation. So this is how we see that it is completely balanced with the earth's surface. So to this balance of incoming and outgoing rays of the sun is known as heat budget or heat balance of the earth. Now this heat budget, in other words, we can also call it as a vertical transfer of heating or vertical movement of heat energy, that is from incoming till outgoing. But the heat transfer also takes place latitudinally. When we talk about latitudinal heat transfer, we say through this understanding that not all the place on this earth's surface experience the same amount of heat. That is, the insolation received in a place is not the same. For example, the lower latitudes experience good amount of insolation as compared to the higher latitudes. So, if we see onto the latitudinal factor, at 0 degree latitude or in and around 0 degree, the heat received is maximum, or the insolation received is maximum because of the sun's movement that takes place between 23.5 degree north and south latitudes. So, these are the zone where maximum insolation is received as they are receiving the vertical rays of the sun. But as we go higher the latitude, the heat received is minimum, or in fact you can say the insolation received is less, because they mostly receive the slanted rays of the sun. So, in this case, we also see that the higher latitudes are mostly covered by snow, and here it's maximum radiating back rather than receiving the insolation. So, what we find the difference is at lower latitudes, insolation is maximum, and at higher latitudes, radiation is maximum. So, this results, or this imbalance in the heat at higher latitudes and then that of lower latitudes, results in the formations of winds and ocean currents. So, these winds and ocean currents thereafter act as an energy for transferring heat from lower latitudes to higher latitudes, and then from higher latitudes to lower latitudes, maintaining a latitudinal balance of heat. The colder winds and ocean currents starts moving towards the equatorial area, while warm winds and ocean currents from the equator starts moving towards the polar areas, and this way there is a balance been maintained of the heat to what is we call latitudinal heat balance. So, this is for the class today. Thank you very much, and you all stay safe.